Are solving one-step inequalities. Yesterday, we learned a little bit more about what inequalities are and how to graph them. Inequalities are things that are read as less than or equal to, greater than, and greater than or equal to. When we're solving something that looks like an equation with an inequality, it actually solves exactly the same as an equation, except when we multiply or divide by a negative. That's our one special case. And when we do that, we're going to switch the direction of the inequality. So instead of reading less than, it will now read greater than. I'm going to show you why this is true. Here we have an inequality that is already true. 4 is less than or equal to 12. So I'm going to add 4 to both sides. And what happens? I get 8 is less than or equal to 16. This is still true. So we can add things to both sides. When we divide both sides by 4, I get 1 is less than or equal to 3. And that is still true. So that division by 4 is fair game. When I subtract 4 on both sides, I get 0 is less than or equal to 8. And that is also still true. When I multiply both sides by -4, I get -16 is less than or equal to -48. And you may be tempted to say this is true, but -14 is actually smaller than -16, so that's false. When I multiply by 4, I get 16 is less than or equal to 48, and this one is true. And then when I divide by -3, I get -1 1/3 is less than or equal to -4. And once again, you may be tempted, but this is false. So what we're going to do to make this true is to just change the direction of the sign. If I rewrite this as -16 is greater than or equal to -48, it works perfectly. And same thing with this one. So that's how we're going to adapt. So let's go and do some examples. I'm going to show you the highlighted ones here. These are just one-step inequalities. You'll do more complicated ones later. I'm going to draw a line at my inequality, and I'm going to undo subtraction by adding to both sides. And adding was okay. It still kept the inequality the same. So I have x is less than or equal to 16. Now, because I want to represent all of the potential solutions to this inequality, I'm going to graph it. So I need to make sure I have 16 on my graph and that I also have the numbers around it. And let's go ahead and put 0 on there just for kicks. I'm going to do my circle. This is an equals, so I'm going to fill it in. And then x is less than or equal to 16, so all the numbers that are less than 16 go to the left. Pretty easy. Now let's look at C. I'm going to solve it just as before, but now I'm going to undo division. Now, we said that when we multiply or divide by a negative number, which I'm doing because the negative number is the one that's at the bottom of the fraction, then I'm going to flip-flop the sign. So now it'll read like this. Oh, I'm so sorry. This shouldn't be 20. This should be -4. Now I'm going to graph it. That's it. You just need to flop the direction. So I'll circle my 4, and then n is greater than because it's on the bigger side of that sign. So I'll draw an arrow to the right. Okay, let's look at D. I draw my line, and to undo multiplying by a fraction, you multiply by the reciprocal. That's how we divide. And I'll get n, and on the other side, I'll get -30/4. which simplifies to negative 15 over 2. But which direction should my sign go? I multiplied, but I did not multiply by a negative. This thing that I did was not multiplying by a negative. I multiplied by a positive. So I should keep my sign the same direction. And then I'm going to graph this on my graph. Negative 15 over 2 is like negative 7 and 1/2. So I'm going to put negative 7 here, negative 8 over here, and negative 6 over here. Negative 7.5 should be right there. And that's my circle. I'm going to change colors to make this a little easier. N is greater than because it's on the fatter side, so it'll go to the right, and it could be equal to, so I'll fill in my circle. Let's just do one more. On this one, I'm going to undo division by multiplying. And what I did was I multiplied by a negative. So this is a time when I switch the direction of my sign. And I'm going to do my circle and go to the right because x is on the fatter side of the inequality. Hopefully that clears up some things. Let's remember a few key points. Just because there is a negative in the problem does not automatically mean that you switch the direction of the inequality. It's only when you multiply or divide both sides by a negative that you change the direction. So we saw that on example D. There was a negative in the problem. We were multiplying, but it wasn't the thing that I had added. And the solution to an inequality is all the numbers that make the inequality true. So when we're talking about x being greater than negative 10, that means that the solution is all of the numbers that are greater than negative 10. That's 5, that's 500, that's 100, that's pi. Whatever number you can think of that is negative 10, it is a solution. That's why we need to do the graph, because that way we can show all of the solutions. Our solution is all of the points on that arrow.